A4i.tv. The world's first internet TV channel fully dedicated to trussing and rigging. A4i.tv. A4i.tv. Rigging and trussing television. Be the first to see the newest and most dynamic videos on A4i.tv. The world's first internet TV channel fully dedicated to trussing and rigging. A4i.tv. A4i.tv. Rigging and trussing television. Be the first to see the newest and most dynamic videos on A4i.tv. The world's first internet TV channel fully dedicated to trussing and rigging. A4i.tv. A4i.tv. Rigging and trussing television. Be the first to see the newest and most dynamic videos on A4i.tv. The world's first internet TV channel fully dedicated to trussing and rigging. A4i.tv. A4i.tv. Rigging and trussing television. Be the first to see the newest and most dynamic videos on A4i.tv. The world's first internet TV channel fully dedicated to trussing and rigging. A4i.tv. A4i.tv. Rigging and trussing television. Be the first to see the newest and most dynamic videos on A4i.tv. The world's first internet TV channel fully dedicated to trussing and rigging. A4i.tv. A4i.tv. Rigging and trussing television. Be the first to see the newest and most dynamic videos on A4i.tv. The world's first internet TV channel fully dedicated to trussing and rigging. A4i.tv. A4i.tv. Rigging and trussing television. Be the first to see the newest and most dynamic videos on A4i.tv. The world's first internet TV channel fully dedicated to trussing and rigging. A4i.tv. A4i.tv. Rigging and trussing television. Be the first to see the newest and most dynamic videos on A4i.tv. The world's first internet TV channel fully dedicated to trussing and rigging. A4i.tv. A4i.tv. Rigging and trussing television. Be the first to see the newest and most dynamic videos on A4i.tv. The world's first internet TV channel fully dedicated to trussing and rigging. A4i.tv. A4i.tv. Rigging and trussing television. Be the first to see the newest and most dynamic videos on A4i.tv.
Good morning, everybody, at least the people in Europe, and I should say hello world. Welcome to the first Prolyte webinar ever, which on one side I have the smallest audience here in the office or in our small studio with 4 people. More is not allowed in the Netherlands. And on the other side, at your side, we are in total with, when we are complete, in approximately 250 people. So I have to say hello, bonjour, guten tag, privyet, ni hao, name them all. Very welcome. The next hour, I'm here for you. We're going to do something about Truss. I'm going to tell something about Truss, and actually we're going first back to the basics. Why are we going back to the basics? I'll never forget that we had a training course with the Excel program. And in the Excel program, the people said, do you know something about Excel program, how to operate it? Yes, of course. We know how to multiply, we know how to divide, and of course we have the magic auto sum. So let's do the next course, because we already know the basics. We started the first lesson, and actually after half an hour, they said, man, we don't know shit. We don't know nothing about Excel. So please start just from the front. That's what we're going to do today as well. That reminds me of how did we enter into this industry? How did you enter this industry? So it's a journey from the early days until now. So, but we can start the presentation now. It's back to the basics. Yeah? We go back from a time where we used real letters as truss. Today's menu, small introduction. Who am I? Because I still did not tell you who I am. I will do that in a minute. Tell you a little bit about connection methods, the layout of the Prolyte truss. Compatible or connectable or comparable, could be anything. A little bit about forces on truss, loading tables, and we're going to end with a live load test to see if the reality meets the calculations on paper. That's not something we do often for audience, but today we're going to test this and show you if we are telling the truth, yes or no, or if we do our mathematics, okay, yes or no. So it's quite exciting, and I hope. There's also Q&A. We try to, you are able to type in. If there are any questions raised, then please type it in. We will try to answer them every 15 minutes. If you are with 250 people and we got 250 questions, then we need another 4 hours. We only have 1 hour, so it could be that some questions are picked out and some will be answered later on, or afterwards I will send it over in an email to you. So let's start. Why do we do it? It's all about safety. We still see the daily practice where people think how you can connect two trusses with each other, but it's quite easy to forget something, what you can see here on the picture as well. And maybe it's done on purpose, maybe it was for training purpose, I don't know, but it's just what you show in a daily practice in pictures we receive or we see on social media or whatever. That reminds me actually that we go a little bit back in time. But first, let's start to introduce myself. My name is Eric Laanstra. I'm the product manager for Prolyte, and my journey in the entertainment world started actually somewhere approximately in 1984. That means I'm not 32 anymore. I'm already an old guy, 55 years old. But nevertheless, I started in 1984 as a DJ, and that's what you see now was my first drive-in show, and I was very proud. And if you turn off the switches, then everything was under power, so you had to wear gloves to operate everything. But at least you had to start somewhere, and I started as a DJ with my own drive-in show. And later on in 1986, there was some other company who came in and showed their drive-in show, and that was my first experience of Truss. So, and that particular day, I had my first lesson in how to build a truss structure. What you can see, there was one guy who was operating everything, and he's managing the lights on the truss. And you have 3 people watching to see how he does it. And normally you hang lights underneath your truss, but he started on top. So what? How do we do it? What do you need to take into consideration? So that was quite exciting. So in the end, we built a magic show. We thought at that time in 1986, oh, wow, man, this is fantastic. This is really fantastic. And I got such a feeling with it. I said, okay, I want to go on with lights, with trussing. So I started in the live music later on, 1 year later. And finally, I went with my first band to the local pub, and I had with me my 4-way remote control, which I operated in total 12 par 64 cans. And it was really a crazy time, and they were, wow, this was magic. So continuing that all through over the years, finally in 2000, I make a big step now. I started at Prolyte, so working 20 years for the company now, and to see the other side of the industry. So from a user, you go to a manufacturer to see behind the scenes what's all behind the truss, because you see a piece of aluminium, but there is a certain philosophy behind the product. So from the first moment, they say at Prolyte, well, Eric, welcome, but it's about think safety first. So it's quite important that everything should be safe. We operate above people, above stages, so it needs to be safe. But also you need to learn how to work in a safe way, not what you see now on the picture from, yeah, okay, nice. So work safe. If you then go to the theater and you expect as audience that you are safe and that the artist on the stage is also safe. But we also can imagine that if you are on the road and you don't have the proper material with you, 8 o'clock is showtime, the show must go on, and you have to actually perform in the best way you can. What you see here is they found a solution, but if this is the best solution, yes or no, decide it yourself. It's the same with how do you connect the truss? What is the best way to connect the truss with each other? And can you connect trusses with different connection to each other? You can. This is the most cheapest connection system in the world. It's called the tie-up, and you can buy them per 100 in a plastic bag at your local store. But of course, this is not the way. You don't want to stand underneath such like that. How do you pick a truss up? You see that often. We call it in the Netherlands, we call it the spijltje, and you put your hook on the chain around the tail and you pick it up. Is that allowed? Yes or no? Is that wise to do? Yes or no? But you see, it's still daily practice. If you don't have enough square truss, then you can use triangular shaped truss and you can connect them to each other. It's all possible. Although normally the holes of the square truss are under 45 degrees, and for the triangular shaped truss, they are under 60 degrees. So it's quite a complex situation here. Wear and tear. And until what moment still can you use your truss? It's a complete other subject, but this is still what you see. So if you use the material, it should be in a proper condition. It's the same as if you forget stuff, you don't have pins enough, don't put your safety clip as a pin in your truss. That's not the right way to do. Homemade structures. If you have a very nice backyard and you have a birthday party in your backyard, you can build, of course, your own homemade roof system. And if you have, by the way, some animals or a neighbor who has an animal, you can borrow a stack of hay, so you can create your own rafter for your own roof system. So there are lots of ways, and we are creative in this industry, just creating structures, but we should do it in the right way. And we first start just with the basics. Actually, I have a piece of truss here, but what is it actually? And why are certain things in it? Well, the truss is a lattice structure. That means it's open triangular shape. So if I made a triangular shape and I have hinges in the corners, I can push in any directions, but it doesn't change its shape. If you compare that to a square, if you put force on one side, it starts to deform. As you put a diagonal in, that means that you are creating two triangular shapes again, so that makes it actually a fixed construction again. So it cannot move if you put a force on one side. Well, then we have the cross sections, and we're focusing on the multi-purpose series. Multi-purpose series is the 30 centimeter and the 40 centimeter truss. So we have them available in a 2-chord, a 3-chord, and a 4-chord truss, which is the ladder, triangular, and square. For the 4-chord truss, we also have available a rectangular shaped truss. And if you go to the bigger series, we also have foldable trusses. And then you speak about trusses of 52 centimeters high or 1 meter high. Well, what are the basic elements of a truss? We have a main chord. If you have a square truss, in this case, we have 4 main chords. We have a diagonal member. And that thing, this particular member, is called all around the world, it has different names. some call it's a brace, it's a diagonal, it's a filler. So spijltje in the Netherlands, you see that a lot. But since we are an international company and we have international clients, but also based on the standard the EN 17115, we like to use the same terminology. That's a difficult word. At least we want to name the parts the same. So that means we are now talking about a diagonal member so that everybody knows if there is a problem with the truss, with that member, that you know how to call it. In the end, of course, we have the connector. We have an end member, this one here, and we also have an internal member. All those members we are going to discuss a little bit later on why they are there. All those members create, of course, the node points, and the node points are the points where the truss is normally the strongest and where you normally can pick up the truss or suspend something from the truss or very close to that node point. Then, of course, we have the connecting elements. In this case, the eggs, the pins, which forms the connection between two truss modules. Then a little bit about the explanation of how does it work at Prolyte. Because we name our trusses, we have X, H, and all those kind of things, 30, 40, 100. What does it stand for? Well, the first letter states something about the type of main cord, actually the size of the main cord. We have an E, we have an X, we have an H, we have an S, we have a C, we have a B, we have a D, and we have an M. And all those letters are standing for the size of the main cord. And the most popular one from the old days on is the X series, 51 times 2 mil. Later on, we came with an H, which is 48 times 3, an S, super truss, and then later on we had a B, big truss, and we had an M as the mammoth truss. The numbers behind that, so an H30 or an S52, the two numbers behind that are standing, that says something about the height of the truss. So an H30 is approximately 30 centimeters high. We rounded up until round numbers. Actually, it's a little bit lower, but we said, okay, it's about 30 or 40 or 52. That says something about the height of the truss. The last letter is a little bit complicated because that's partly based on the Dutch language, it's partly based on the English international language. So the L stands for a ladder truss, the D stands for a triangular truss. D is actually in Dutch driekant, or in German drijkant. So for the German guys, we're still okay. The English guys, so the D is D. Then we have the V for square truss, which is in Dutch vierkant. In German, I think it's the same, vierkant. Yeah. And later on, we had the rectangular, the tower, and the folding truss. Then we went on to the international. So it's not actually completely logic, but we are not, because the first trusses available were according to the Dutch language, and later on we went to international, but actually it's too late to change it now because everybody worldwide knows now the codes. Normally there's a sticker on the truss, so you can actually see what kind of a truss you have. Just in case, if there is no sticker on the truss, you'll still be able to recognize what kind of a truss you have in your hands or in your warehouse. So we marked the connectors. The connectors is marked if you have one ring, see the blue arrow, then you have an X coupler, so that means that your main cord is 51 times 2. And if it's an H, it has 2 rings, so its main cord is 48 times 3. Well, why do you do that? Of course, the strength of a 51 times 2 and a 48 times 3 mil main cord is of course different. Also later on, if you've used the truss for a year and you want to inspect it and there is no sticker anymore, you need to be able to recognize the truss. So that's why we said, okay, let's mark that so at least you know you have a perfect identification of your truss. Then there are all kinds of coupling methods. So to connect two trusses together, if you start with a tube coupler, the tube coupler is actually the most cheapest solution, but it's also most often used in fixed installation job, like in shop fitting, where you have connection points enough. Disadvantage of that is, of course, that it's quite time consuming to make the connection because you need to put 8 bolts in, 8 nuts, you need to tighten them. So for the rental, it takes too much time. Plus that the hole of the bolt is always bigger than the bolt itself. Otherwise, you cannot get it in, of course. So that means that the chance on a deflection at your connection point is quite big. Plus, if it falls by accident on the ground, the tube ends easily can get damaged. So if it gets damaged, it's not round anymore, but you get an oval shaped form which does not fit anymore. So for fixed installation jobs, I think it's a fine and good solution. And of course, depending on the application, load capacity and everything, but that is fine. End plated truss, gusset plates, it has all kind of different names, but at least that there is an end plate to a truss and you bolt them together. This gives a little bit of reduction in loading capacity because the forces need to be transferred from one truss module to the other one. And normally perfectly it should be in one line, but now it has to go over the plate, over the bolt. So that gives a small reduction in loading capacity. Plus on the bottom side, you will see you have an open end between the main cords, and from a visual point of view, sometimes people don't like that or whatever. It's still used a lot, of course. It's in the US or tours which come in from the US, they use a lot of plate truss because they are used to it. It's more or less the standard over there. Then we have the pin 4 connection. The pin 4 connection is most of the time orientated by male and female connectors. The truss length is not a using length. Sometimes that can be a disadvantage, and as soon as you got some wear on your connection, it immediately results in a deflection of your truss. But if you use a male-female, then you need to think. So if you need to build a truss grid, then you need to know upfront in which direction should I put my truss. So that could be a disadvantage of a pin 4 connection. Although for bigger truss series, we also use pin 4. It's much easier than putting such an egg in with a 4 hammer that you need to smash your pin in. So in that case, a pin 4 is quite okay. Then the most recognizable connection, which a lot of people, a lot of manufacturers use now, is the conical connection, and it's an exact alignment of the elements. You have a 100% rigid connection, which normally means if everything is in good condition that you don't have a deflection in your connection point. And that's of quite a big importance, because we don't like, if we use truss, we don't like deflection at all. Actually, a truss should be staying in a straight line, as straight as possible. And sometimes possible, sometimes it's not, depending on the size, the loads, and everything. We get on that later on, of course. For the people who are not so familiar with the conical coupling system, that means you have an egg that's put in the middle. You can use a pin with an M8 nut, or you use a pin with a safety clip. The pin with a nut is most of the time used for dry hire rental, so that there's all the pins and the eggs will not disappear somewhere, but they're already pre-mounted. The advantage of the pre-mounting, it saves you also time, of course, on site. So if you enter the venue, you need to build up your truss grid, then it saves time in connecting. Make sure you always use the proper material, because if you don't use the proper material, you might end up with a deflection in your connection system, what you can see here. And of course, we understand sometimes it is, you should not do this. Let's be honest. And depending on the quality of the bolt, you don't know what the quality of that bolt is. Maybe the user in this case did. But if you see this is not the way we want to connect the truss. But it's still daily practice. According to the EN 17115, we also, as a manufacturer, need to tell you what we recommend as a tool. It's a recommendation. It's not obligated. Of course, everybody is free to use their own tools. What we do not advise is, of course, use a steel hammer, because if you miss your pin and you hit your truss or your main cord, the steel is quite hard than aluminium, so the aluminium gets easily damaged. Plastic hammer you see a lot. It's pretty okay to use, but sometimes you have the plastic hammer. If you use the hammer and you smash it, then it bounces back, so that means that you could hurt your poles. Some companies use hammers with heads which is filled with sand, so that's, you don't get that bounce back. That's of course pretty okay, but as a manufacturer, we always advise to use a copper hammer. That is the most expensive solution, but on the other side, it protects the truss the most, and has to do with the softness of the copper. So if you miss your pin, the chance that you damage your truss is low. And of course, if you do your best, it's even possible to smash a copper hammer, but that's not what we prefer, of course. Then a couple of years ago, we came with what they call so-called Gardena truss. There was somebody posted this one on the internet, and we got a lot of reaction from, hey man, what is that? Well, that is the Verto system. The Verto system you can see still here. I will remove this one, so I can lower this one a little bit. I'm a big guy, but not that big. How does it work? It's actually a rotating system for the people who don't know. And it has a steel hardened coupler like this one, and you could use where it's necessary to use in secondary safety. You could use a safety clip as well. The nice part is you don't need to hammer anything in anymore. It's just an egg which you put in, you turn it, and it's done. Why did we do that? Now, the reason why we did that is that actually since 1991, from the top of my head, when this truss was introduced, nothing changed anymore. We didn't change anything. So that means there must be something wrong. This is not the Utopia truss, although we think it's quite a nice truss, of course. But nothing changed. So at a certain point, we discussed with users all around the world, so what could be possibly wrong with this truss, or what is the most common complaints here in the industry? Well, that was exactly the noise and the speed. And companies get less and less speed to get in the venue, to do the load in and to do the load out, because time is money. As soon as one show is done, please get out as soon as possible, because the next trailers are already on the other side of the venue. So that's the reason why we came up with this one. Plus also for congress halls, for example, or venues where double duty is possible. Also for hotels, for schools. That noise can be an issue. So that's the reason why we developed this one. It's actually quite simple. You put your connector in. The nice part is if your truss is somewhere flat on the ground, you're still able to rotate it. That's the question we get a lot. Is that possible? Yes, no. Just put them together and you can turn it and it's fixed. If you turn on the right ring, of course. But I have to look into the camera. So done. Actually, in a couple of seconds, you're done. Even with disassembling, if you do a job in a hotel during a wedding, and after the wedding, everybody goes to sleep, and you need to break down your truss grid, it's quite easy. That without any noise, you can put it in and out. So that is really fantastic. The nice part is there is a blue cap inside. It's of course the Prolyte blue color. And you can play with it all day because it can go backwards. That has to do with the functionality. On the inside, there are some ball bearings. Ball bearings needs to be covered. So when it's opened, it comes to the front. And it protects the ball bearings against dirt coming in. The nice part is also that you're not able to close your connection. It's actually an extra safety. So you're not able to close it. You first need to put it in, then you can close it. And of course, there are always smart people say, yeah, but I don't have connectors enough, so I put my finger in, then I close it. I should not do that. There's a Verto. The nice part here is also the whole connection system. Yes, it's a little bit more expensive, but it's not welded to the truss anymore. So that means in case of a damage, you only can replace one connector or let it replace by somebody who is able to do that with the proper tools. So that might extend the lifetime of your truss. So, back at the presentation, you see here the red area. The red area normally means in the entertainment world, red is danger. When you're at home with your wife, it could be love, but we now talk, although I love this truss, the red part is still, of course, danger part, so that needs to be closed. So you can recognize if a connection is not closed. So if it's turned, red part is away, then it's okay. Grooved grid ring, and of course the ring, if you untie this one, you can turn it out and you can replace it when it's damaged. It's fast and foolproof assembly. What do we mean with foolproof assembly? The foolproof assembly part will come back in a minute. In this case, it's the toolless system. It's quiet. Forces are distributed through the main cords, exact alignment of the elements, and of course, it's an easy to check connection because as long as you don't see red, you're fine. Since this one has quite narrow tolerances, we needed to create a new box corner for it as well, actually for two reasons. We wanted to have a stronger corner connection because a corner is always the weakening part in your structure. So that means if we increase the strength of the corner, you can increase the total loaded capacity of your truss structure which you build. So in this case, the 2D or 3D structures can be built without losing voluntary strength because it's fully plated. If you have the, I don't have it, yeah, it's somewhere here on the ground. If you have the conventional box corner, it's welded and the diagonals are welded in it. And for the people who don't know, as soon as you start to weld an aluminium, it immediately loses 50% from its capacity. So that's the reason, hey, if we're going to bolt it, the truss could be twice as strong. So it would be great if you could bolt this truss. It immediately, but nah, we're not that far. Plus an exact 90-degree shape is guaranteed. And we have in the last 20 years, the box corner has been redesigned. So there are 3 different types all over the world available. And normally they have been heavily used. And if you heavily use people, then the chance is that it starts to deform a little bit. So there might be a chance that your regular box corner does not fit with a Verto. And that's the reason why I said, okay, just to avoid that, they use the HD box corner. It's suitable in combination with a 30V. This is the 30 centimeter truss, but on the back side we also have a 40R and we have a 40V. So 3 series of Verto. I think we have a question coming in or not?
Yeah, we have 2.
Yes.
One is regarding the corner blocks. Why most truss manufacturers do not braid the corner blocks, from Anthony.
Why do people not braid? Yeah, that's a little bit, yeah, that's a good question. I come back on that one later.
Yeah, and we have a question if Prolyte truss has an expiry date or the aluminium will corrode, from Melvin.
Yeah, when has the truss an expiry date? How long lasts aluminium? That's of course depending on the area where you use it. If you use a truss continuously on the seaside, then you will notice that corrosion will start earlier. But if I have a truss structure here, and after 20 years I come here, it will still be up in the air. So the lifetime of the truss is depending on how heavily is it used, plus in what kind of environment is the truss used. So there's not a specific number that after 6 years your truss is not usable anymore. To come back on the box corner, a box corner is never a standalone part, and box corner is always part of a complete structure. So that means the box corner are the box corners are calculated. We do have strength figures available, but since it's always used in combination with a complete structure, the whole complete structure needs to be calculated. So that can be can be determined what actually the determining factor of that structure is. Those were the questions for now?
Yeah.
Okay, let's continue about the layout. If you go back to the truss, where is it? Here it is. Then you see that the truss has diagonal members. And diagonal members are placed in a particular way. There is a philosophy of how the diagonal should be placed. In our philosophy, and I think of most manufacturers, is the ideal line is where the diagonals come together, that they meet each other somewhere in the middle of the main cord. If they meet each other in the middle of the main cord, that's where your truss is then the strongest. So if I pick it up here, or I'm going to suspend something from the truss in or close to the node point, that's where the truss is the strongest. That's why there is a certain distance. We get a lot of questions is, I'm not able to put my clamp. And if you have, the most clamps are 50 millimeter or 30 millimeters wide, I'm not able to put my clamp in. Well, in this case, you're indeed not able, a sling can be put in between, but a clamp not, but it has to do with that we want to meet, if the angle in this case is 45 degrees, that we are somewhere by 23 to 25 centimeters, so that we are somewhere halfway this section. If we widen it up, that means that they meet each other outside the main chord, which gives a chance of a local bending moment. So if I put a lot of force here, I think that is more easy. If you see, there is a lot of space here. So if I put a lot of force here and I start to pull here, you can imagine that this one can have a what we call then the local bending. That's the reason why it's here. What you also see is that the diagonals are placed sometimes a little bit different than another truss manufacturer. If I, for example, I have one, I think here. Where you see it's the arrow is pointing in that direction and it keeps pointing in that direction. So they all go in the same direction. What you see at Prolyte is that this one that point in that direction, and this one is pointing in that direction. So we what we call we have a 4-point knotting, which you don't have here. That does not mean that this is bad and this is good, but it's depending on the philosophy behind that product. We tried actually to make the life as easy as possible. So I have to pick this one here. Because due to the 4-point knotting, that means I kept myself a lot of space between my node points. If you compare that to this one, then you see that I only have a small place to put some lighting figures, because this one is already here and that one is already here. If this one would have been placed here, then I got already twice the space. So that's the reason why we have the 4-point knotting, to give the light engineer as much space as possible to suspend whatever needs to be suspended from the truss. So that makes us sometimes a little bit different than the other. But everybody has the reason for there, and everything has its advantages and disadvantages. We'll get back to that one as well. This is what you see, the local bending moment, if the diagonals don't meet each other in the middle. And if you see the picture underneath, I hope you can see that's what you see, that the diagonals are placed more outside. Of course, that stays on diagonals, but that also has a complete different strength than when they meet each other. It also does not mean that that is a bad truss. If it fits for purpose, if you say, okay, I'm using it for decorative purpose, I only need to suspend 2 kilograms each meter. Hey, why not? But it's, in this case, this is used also in rock and roll, and we want to put heavy loads on as small as possible truss. The smaller the truss is, the better, because it saves on transport. Then we have the cross members. We don't have it here. That starts approximately from 2 meters, and the 3 meter and the 4 meter section. The 2 meter section has 1 cross brace, and the 4 meter section has 2 cross braces. But we also have cross brace here. And what you sometimes see, by coincidence, I'll take the same truss, they don't have it. We do have it. Why is that one in? Actually, for 2 reasons. The one in the middle, that protects your truss against torsion. So we like to have balanced load. So if I load here 100 kilograms, I need to load 100 kilograms here as well. This is the utopia situation, but we also know on the daily practice that sometimes that's not always possible. So that means that sometimes here is more load than there. So then a truss tries to deform. It was on one side. Now with a diagonal placed in between, that saves a little bit on torsion and it protects a little bit on torsion. It's actually the same here. This guarantees more or less also a shape. If it falls for one or the other reasons due to the internal brace here, it protects a little bit the shape of the truss, and it's also protected against torsion. Why do we do that? And why is that one here not in? I didn't spoke to the manufacturer, but you also can see there is a difference in truss. You can see that the brace here is bigger than that one. That had to do also against with the philosophy. We always believe in lightweight systems because the truss is not always the determining factor. That also could be a suspension point here. I'm here in a small building, so I think that this truss is stronger than the connection points can have. And if I only have a connection point or a suspension point in the ceiling which says, okay, you can hang 250 kilogram here and 250 there, 250 there, and 250 there, that means the less weight on aluminium I put in the ceiling, the more sexy lights I can hang from it. Because truss is not sexy. I think this is sexy, but the regular truss, this is not sexy. But my new moving head, that is sexy. And I just need a piece of aluminium to suspend it from. So that's a little bit the difference, but we try to make it sexy because it's lightweight. It doesn't weigh anything. It's only 6 kilograms each meter. Everybody can lift it. That's the reason behind also a little bit of why we use, in this case for the 30 centimeter truss, we use a 60 millimeter diagonal, which is destroyed here, as you can see. Because normally I use this truss for inspection, so that I can show can I still use it, yes or no. That depends. That will be explained another time. But not now. We only have 1 hour. Where are we? Whoa. We need to hurry. It's too much fun here. You like it so far? I hope. You may applaud. All truss modules also are determined by end members. The end members, there's this one. This one you knew. So each truss module can be used on its own or in combination with another truss type. The direction of the webbing, that's also what we got a lot of questions about. And normally we like, if you put one truss to the other, that the pattern, the zigzag, what is also called, that it continues. That's a must. And the other picture below, you see you will have 2 parallel running braces. So one module is connected to the other one and the modules are parallel. A lot of people say that is not allowed. Well, for Prolyte, top is okay, below is also okay, because our loading figures are based also on that configuration. Because we know it's happened, because if you don't pay attention, you should not pay attention. We should make the lives of the people who are building truss as easy as possible without thinking too much. We always need to think, of course, but we try to make life easy. The only thing what changes is the way of where the forces run in the truss. So they are designed and calculated for this. I'll do this one a little bit quickly. If you don't have an end member and you don't have the parallel running braces, that could be not so good, because then you immediately lose, you might end up with a loss of loading capacity of 50% minimum. So then it is a must that the framework goes in a zigzag pattern. Now, assembling different brands of truss, it's also always a hot item from what is allowed and what is not allowed. So many questions about, so many arguments about that. Can we connect a truss piece A with a truss piece B? Well, the nice part is it your truss? Did you pay for the truss? If it means complete property, is it your own property? You can do anything what you want with it. That's up to the user. It's up to the manufacturer to decide what do we think, what do we like to explain. Because there is a difference in compatible, in connectable, or comparable. I have 3 different words. This is a Prolyte truss. This is the same truss. It's nice, to have so many trusses. We have another one here. It's all 50 centimeter long and it's all 30 centimeters wide. And I have a truss here. And I have a truss here. 5 different brands. They all look good. It's all fine truss. Okay, can you connect them? Yes. Not perfectly, but if I hammer really hard, they get it in. Yeah. Well, I want to connect. Good. Yeah. Wow. This one fits the wall. This one. Yeah, also fit. Also fit. They all fit. Prolyte fits to everything. So if you buy a Prolyte Truss, it will fit on any brand. No, this is just a joke. You see 5 different brands and they all are more or less the same. Am I allowed to connect them together? Well, I have loading figures for this truss. I have loading figures for this truss. So I'll take just the weakest one, I connect them together and I'm done. That's up to the user. We cannot forbid it, but we don't do it. We always say, don't mix up, because you don't know what something here is on the inside. You become actually the manufacturer of this connection. If somebody signs it off, hey, you're fine. It's no problem at all. It's still up to the user. Can you combine 2 truss brands in one truss? That's possible. Can I connect 2 truss brands in one span? Everything is possible. But we do not like it, because if something happens, you always need to explain everything, why it happened, and that could cause problems or not. Plus, is the truss the same? Is it compatible or is it connectable? But you can see here with my Prolyte truss. Here. If I take this one, this looks pretty much the same. 4-port knotting in braces. Okay. Take a look here. This is not a truss. There is no diagonal. It doesn't matter. They have another size. So this one is connectable, not compatible. So you can continue whatever you want. This one is complete. It has another layout. So it's another truss with other specifications. Same here. Do you like that? If you see that, and then it's completely something different. Somebody starts from an architectural point of view, also can start to complain. So there are so many reasons not to do it, but we also sometimes understand that people do. But it's, yeah, nothing is against the law, but it's up to the user. Where we promote, don't put different truss bands together. It is possible. But you see here as well, the connection is quite good. Here are all the pins in, but you see that the distance from the end of the truss to the end brace is different than on the left side. So that means, is it connectable or is it compatible or is it comparable? It's always nice discussions. It's all about the responsibility and the liability. And we always say, choose Prolyte. Of course, because I am Prolyte. We are Prolyte. Plus, the connection is not the biggest problem. If you have load structure and by the end of the evening you need to disconnect it, you might get in trouble and you get to know your colleague in a complete other way than you usually do. Or you might opt something like that. If the connection on the inside is not 100% perfect, that means you can get a weakening factor over there that you can destroy pins. Is that possible? Yes, we did. It is possible. You test them yourself. But if you have done that, that also could mean, of course, if you see pins which are bent like that, that also could mean that you have overloaded your structure. There's no other option. So are they good or bad truss systems? That's something you have to decide yourself, of course. I cannot decide that for you. But you should always have a reason for your decision. Why are you using Prolyte? Because of the product range. And we have truss, we have roof systems, we have stage jacks, we have chain hoist. That could be a choice. Could also be the relation. I may not be the most important person in your life, but just hope when you hear my name, you smile and say, man, yes, my friend. I saw him on the internet. Could also be the availability. If you take a look worldwide, Prolyte is available worldwide. And here it's just a short map, but to at least to give you some numbers, these are registered partners, rental partners, whatever you can register on the website so that you will get on the screen. I have here then more than 200 addresses worldwide. Could also be the support, engineering support, customer support. We try always to give the best solution. Do we always succeed? No, of course not, because we are also people, we're not machines. But at least we do our best. And of course, the price, we try to have a good quality against competitive price. Sometimes that's good, sometimes we fail as well because we're not the most cheapest brand in the world. And we know that. All those forces acting on Truss. We have external forces and internal forces. Now, if you go to the external force, you have to take a look inside the truss, what kind of forces and internal forces do we have? Well, we have a normal force, a shear force, and a bending moment. The normal force acts in the direction of the center line. The shear force acts in 90 degrees of the center line. And the bending moment causes a rotation around the cross point of the normal force and the shear force. Now, they act all those internal forces. The normal force always acts tension or compression. So if one diagonal member is under compression, the other one is under tension. And if the upper cores are under tension, then the bottom cores are under top cores are under compression and the bottom cores are of course under tension. That has to do with the gravity, because everything we throw up automatically comes down. Also with truss span, truss always wants to come down to the ground. So the forces needs to be transferred over the connection system, what I already explained a little bit earlier. You want to have a straight line through the main cores and not over all kind of corners and a bolt. Cheers, guys. I shake a little bit. It's to the shortness of water. I have a question coming in.
Yeah, this is still regarding lifetime and corrosion. From Elias, who has found corrosion which is located in the area of the connectors when using copper hammers. The questions are if we use a different alloy for the connectors, or if we have considered the corrosive influence of other metals like copper or steel.
Yeah, the connectors are indeed from another alloy, and that alloy can cause, used in the surroundings, in certain surroundings, can in time corrosion. Yes, that's true. I hope I have some examples here of corrosion so that I can show you what can happen to the truss. I will try to squeeze that in somewhere. We're already a little bit small on time. The shear force tries actually to cut the material. So if I put my truss on a wall or on a support and you start to load the truss, it tries to cut the main cord actually. And most of the time, the weakest part of the truss, that point will fail first, and that most of the time is the diagonal. On the short span, the maximum allowable shear force is limiting. That's something we need to remind. For example, and most probably this is not very readable. We took here an example on the red line for a B100 truss with a 32 millimeter diagonal member in it, and we compare that with a standard B100 truss with a 48 millimeter, so a bigger one. So on the right side we have a bigger diagonal. If you go on the short span, you will see that I have to read it now. It's 697.9 kilogram UDL, so each meter. If you go to the right side with the bigger diagonal, you can almost hang 1500 kilograms. So by just adding more material on your diagonal, you'll have twice the loading capacity on the short span. If you go to the longer span, we go to the 36 meter, you can see it's around the 52 kilogram, which you can hang in. And on the right side with the bigger diagonal, it's almost 50. It's 54. So that meant 2 kilogram each meter. So the longer the truss span gets, the less the difference in capacity is. So depending on the application, you can make the choice of truss you're going to use. If you need to create a short span with heavy loads, you can use a truss with a bigger diagonal. If it's for a longer span, then the influence of the bigger diagonal is less and less and less. On the other side, the bigger diagonal increases the self-weight of the truss. So it's all about choices. Well, how can you increase the shear force, increase the diameter or wall thickness of the diagonal member? Or you just simply take a bigger truss. Then you have the bending moment as the force which needs to deflect the truss. It's caused by self-weight, life load, environmental issues, influences, but also, of course, it has to do with gravity. Now, the bending moment is again the compression and the tension, compression, upper cores, tension in the lower cores. And The actual bending moment is depending on the height of the truss. The strength of the truss comes from the height. So the long spans, the maximum allowable bending moment is limiting. If we have the external forces, we have live loads, we have dynamic loads, we have environmental issues. For example, if you put a rooftop and you try to create a canopy on the roof, that means that you have to do it proper, because if you get water tanks like that, that increases, of course, a lot of load extra into your structure. Same as snow loads and ice loads. Normally we don't calculate standard with snow loads and ice loads, because if you have to calculate that means we have to make such big trusses for very small roof systems, because snow and ice increases enormously the load to the total structure. Now, to be able to understand the loading figures, you need, and to read loading tables, you need to understand what is in the loading table. Now, in the loading table is, of course, a center point load. That's called the CPL. When you have two supports and you have one load exactly in the middle between those support points. You have multiple point loads. It could be a TPL, a QPL, or an FPL. That means third point load, fourth point load, or a fifth point load. What you see here is the QPL. That means the quarter point load, that one load is in 1/4 of the span, the second one is on half, and the third is on 75%. Then we have partly distributed loads or non-uniform loads. It's always a little bit hard to calculate. How do you calculate that? Well, if you want to be on the safe side, then if the total load is not bigger than the maximum allowable center point load, then you're always fine. But you can always, of course, get help from a structural engineer or somewhere here at Prolyte also. The uniform distributed load, that means that is the actually divided load each and every meter, where the load is equally divided over your whole truss span between the two supports. And there is also a cantilever load. Cantilever load means that the truss sticks out on one side and there it's getting loaded. Then we talk about a cantilever. Well, there is a rule of thumb of how can you calculate the maximum allowable load in a cantilever. Well, the rule of thumb is under the UDL, the maximum of 1/6 of the distance between the supports may be used as a cantilever with the same UDL. That means if I have a span of 6 meters and 1/6, that's 1 meter, I can put 1 meter on that side and 1 meter on that side. I can still apply the full load on the complete span. It can, of course, be a little bit longer. If it's longer, then you need to consult our catalog or a website where you can find all the loading figures, all the cantilever loads for all the trusses available. You have to be careful because this is a very nice picture that you have a cantilever on one side and all the cabling is coming down. You can imagine that the higher the truss kit will lift it, the more load is applied to the piece of equipment, so that you need to take into consideration, hey, if all my cables run down there, you need to calculate that. Well, based on this was quite a professional setup. It should be calculated, of course. Well, all those forces, and as soon as you start to use, the truss is always going to do something that's actually a deformation or a deflection. And the deflection is a deformation on the load, like we do here. This was partly of the test where we test a span of 20 meters to see for, hey, if we apply the full load, what does the truss do? But you always pull the truss downwards to the ground. Well, how much can it deflect? Well, the general rule is the limit for the deflection of the Prolyte truss is 1% of the complete span. So that means if I make a span of 12 meters, it should not exceed 12 centimeters. In some countries, they think that is too much. But from a technical point of view, a truss can handle more. But if you do handle more, for example, if you take a triangular shaped truss on a span of 20 meters under a full load, that means that the deflection will be approximately 1/2 meter, 45 centimeters from the top of my head. As you can see, there will be one big banana above the stage. Well, if you enter a hall and you go to a concert and you see all kind of big bananas hanging, that does not give, you also have the personal feeling of, In 1986, we were our own engineer. We did all the calculations ourselves because we didn't know. So he went to the truss. How much can I load? Let's see. There is still movement, so that means we can load more. Until there is no movement, then you have to stop because then you're fully loaded. That was those days. Now we know better because more numbers are available and we have all kind of people all around the world with a lot of knowledge. We do have structural engineers which we can consult if we don't know. So that's very good. The deflection, the elastic movement for structure under load, deformation by cell weight and payload. Well, you can distinguish actually two different deformations. We have an elastic deformation and we have a plastic deformation. The elastic deformation is actually the safe zone in which a truss is able to move. If you start pulling a truss, you'll see it starts to move. The more I pull, the more down it comes. If you let it go, it always needs to get back to its original position. If it does not come back, then probably you've done something wrong, because then you enter the plastic deformation. That means it is deformed, but it doesn't come back. So the deformation is permanently. Well, if you're in that area, that means that you can actually throw the truss away because it's permanently deformed. You cannot get it back. So always stay on the safe side and always don't exceed the numbers which is given by or a catalog or by a structural engineer, just to be safe with your equipment. Now, when is deflection important? I also got that question from somebody. And when you fix an LED screen, how can I do that? Because if I need to fix an LED screen, I will be suspended completely from the truss immediately. So that means that my truss is not allowed to have any deflection. Otherwise, I will come to destroy my LED screen. That would be stupid. Is there a certain way how we can calculate this? Well, actually, that's very hard because it's depending, of course, on the size of the screen, on the weight of the screen, on the size of the truss, because every truss reacts differently. But for example, if we take this one, the 30 centimeter truss, what you could do is in pre-cambering. In pre-cambering, that means that if I have my truss, like here, that in the top course, I don't put in the normal connector, but I put in a spacer of 2 millimeters. On the bottom course, I put in my regular spacer. If you do that, we give you an example here, with a span of 10 meters, which is built from 2 meter section. If you do that every 2 meters, so 4 connections, that gives you an approximately pre-tension, actually a positive deflection of 50 millimeters. That could help bring the deflection down. The same counts for performance fly systems. If you move Tarzan from the left side to the right side, then you should have actually perfectly one straight line, because it needs to wave, or it needs to fly above the stage like this, and in the middle you should not touch your stage, hurt his foot or hurt his body or whatever. So if you then analyze the loading of truss structure, the type of structure determines the allowable loading. Yeah? How high is it? How wide is it? How deep is it? What kind of truss do I use? It's small truss, it's a big truss. So it's a type of structure you cannot give, okay, on 4x6 you can always hang 1 ton. That's not possible. It depends. Now, loading tables are only valid for simply supported spans. Other type of constructions needs to be calculated. Well, what's a simply supported span? This one. This is a truss which has 2 supports. There could be a hoist. In this case, it's a hoist, or it could be 2 towers, or it could be a wall, or whatever it is supported. If you have that, then you can use this. I don't know if it's readable for all of you. It's depending a little bit on the quality of how we broadcast it. We're truss manufacturers. We're not AV specialists, but we do our best because this is our first time and you can only make one first impression. So in the loading figures, you give the spans, you give the UDL, we give also the deflection, we give them CPL, the center point load, we give the TPL, third point load, fourth point load, and fifth point load, and the total weight of the span. The total weight of the span is, of course, depending on what kind of truss pieces you use. Then do you use 2 meters, 3 meter pass, 1 meter pass, 50 centimeter pass? You also have some text. The text on the loading table, below the loading table, is quite important because that says and tells you something about how the truss is calculated. Has everything been taken into consideration, or do I still have weakening factors which I need to deduct by reading the loading tables? Well, our loading tables is what you see is what you get. The weakening factors which could be there are already taken out. That means the shell weight of the truss has already been taken into consideration. There is also a quite important part, and there's the interaction between bending moment and shear force at a connection point is already taken into account. What? Well, that's a long story, but if I connect 2 trusses with each other, that means here is something happening. This is weakening part of your truss span, that is already taken into consideration. You say, okay, yeah, there is a difference if I build a 15 meter span, if I build it from 3 pieces of 5 meter or 5 pieces of 3 meter. That is a difference. But it's already taken into consideration. There's all times, sometimes is why is one truss span sometimes stronger than the other one. Well, I have here all those different brands of truss, they all have the same height. If they all use the same alloy and they all use the same diagonal setup and it's completely the same, then normally, theoretically spoken, load capacity should also be more or less the same. But it's also depending a little bit on the structural engineer who's calculating it and what do you take into consideration and what not. Do we take an extra safety factor or not? I can tell you, yes, we do have an extra safety factor which nobody knows. That means that sometimes our figures are a little bit lower. But I will show you in a minute during the live load test why that is not really actually a big option, because it's how do you call it? It's crunching behind the comma, what I say. So if you shoot this, what you see is what you get. And the last part to show you if we are really right, we are prepared to do a live load test to see is what we are doing and what we are showing here on paper, if that is really the truth. Or are we better? Or are we even worse? I know it is tricky. It's not a movie. We did not, I'm going to disappear and I'm going to come back in another camera. But what I did here in this room, I put up here a test. I made a span of 11 meters from H30V. And we're going to measure it, the loading. We're going to load it to its max, the center point load. Well, if you take a look at the catalog, the overview, then on an 11 meter span, I am allowed to put in a center point load of 511 kilogram. And if I put 511 kilogram in, my deflection should be approximately 110 millimeters. Hey, that's nice. That's 11 meters with 11 centimeters. That is exactly within the 1%. But that is also what we maximum allow. So we're going to match now the practice with the theory. So that means, shall I move? I move on. See you in a bit. And we're already back. Oh, nice. It's not a movement. It's still 12:03. So that means I'm 3 minutes behind the schedule. I have to wear my gloves. A, to protect myself. B, I hate dirty hands because I always work behind my desk. If you cannot see it, but I wear my safety shoes. So what do we have here? We have here a setup of 11 meters of span. What we did is we put, I don't know if you can see it, but there is a small row behind here, which gives a certain distance to a clamp. The same height is at the end on the right side and the end on the left side of the truss. So that we can measure, we now have here an 80 kilogram. The 80 kilogram is the manual chain hoist, which is connected to the load down below. We have put 500 kilograms of weight below, and we have put load measurement system in so that we can see what we can do. What you also see is actually without hardly having any load on it, we're going to measure it, and we see that the deflection is approximately 14 millimeters. The 14 millimeter with a load of approximately, let's say, is it readable, but yes, that's very good, thank you. So we have now approximately 18 kilogram, but it's its own weight. So now we're going to start to load. It might be a hell of a noise, but that's in the reality, because if you do it in reality, only you should have it. Where are we? Did you hear that? 223. I see what's happening to, I hope you can see it. 414, 430, 500, 507, 510. I leave it as 510.
Remember I told 511, so I'm smuggling 1 kilogram. According to our loading figures, but you can see that there's quite a lot of distance between the wire and between the truss. So according to the table, I should not exceed 11 centimeters. Well, let's hope. Where is it? I'm at 10. Is it visible? Yeah, we got it. That is nice. Okay. That should be the maximum of 11. And we're almost at 100. Yesterday I did a test. The deflection is a linear line. So in theory, if I put half the load on, it should be half the deflection. How is that possible? Right, because we also have a shelf weight of the truss. But the shelf weight of the truss was already taken into consideration. So if we're going to put the load down to 250, there we go. $251. So that means in theory, the maximum allowable load should be somewhere around 55 mil. Hey, that's nice. We're exactly at 55 mil. So that's indeed, if I put half the load and half my deflection. It could be that if I have this span and I put 2 millimeter spaces in the top course with my pre-tension, and then with a load of 250, that means that the 50 completely disappeared. I have almost 0 deflection. There are all kinds of different ways, but it's a little bit depending on the situation. It means, lucky for me, that is what we let the engineering agency calculate. That is also according to the reality. So that's a nice part. You also see that the deflection is a little bit less. If you put on the total load, the deflection is a little bit lower. Why is that? Actually, for quite a simple reason. We put an extra safety factor in it. Because we, as manufacturers, don't know how you, as a user, are building your span. In this case, I use 2 meter section. Maybe you can use 3 meter section. You can also use 1 meter section. If you use 1 meter section, the shelf weight of the span increases quite big, so that also means that your deflection will be more. So what you see is what you get. So for us, it doesn't matter from what kind of components you put your truss span together, you will normally never exceed the maximum deflection we give. I hope it makes sense. Let's go back to the other one.
And I'm back. You can stop the movie now. Now, just kidding. That brings me actually to the end. It was quite exciting. I'm 10 minutes behind. Certain things need to be done a little bit quickly. Did we have in the meantime any questions coming in, Bart? No questions. That means I hope that I made myself a little bit clear. I hope it was interesting for you. Since we were with 250 people, it's the difference in knowledge is huge. So you don't know where to start, you don't know where to end. The nice part is, since this was the first webinar, we just started at the basics. And hopefully there is more to come in this actually a little bit unsecure situation where the whole event branch is in. Then we still have to deal with COVID-19. Normally we do the campuses and we travel to you. That makes you for this year the biggest audience until now. And I hope that the COVID situation quickly will change, and that we are, and in you, especially you are working in the event branch, can have a very nice job in a bright future again. Yes.
I have a question from Patrick. Why we can't hang a square truss like a diamond?
You can, but it's not advisable. The truss is calculated. If you take a look at the catalog, you also can see the direction in which the truss is calculated. If you use it's a diamond shape, there's a lot of things are written about it. You even can find some blogs back on our website why you cannot do it. It's a little bit depending. It's depending also a little bit on the truss brand and everything. What you can see here is if you use it like that, yeah, and you start pulling here enough, yeah, then in media, yeah, it will start to deform. It can quite deform quickly. If you have this one as an extra support, that might help a little bit. It's very hard to give a number. The truss is designed actually, and from the old days, is actually designed to be picked up from a top course and to be loaded on both equal, on this side and on that side, or from the bottom course. It's not designed to use it like that. If you use it like that, it's a little bit depending on what you can have. Actually, there's only one answer. Please construct your supplier what the maximum loaded capacity is or will be. It's also depending on the layout. Does it have diagonals on 4 sides, or does it have on 2 sides diagonals and on 2 sides straight bracing? Then the situation is again completely different. But you need to consult somebody simply due to the fact that this one is not designed and calculated to be used like that. It's not the most easy answer to give on the rating. I can give you a number, but as soon as I give you the percentage, hey, the decreased loaded capacity will be that, then people will start to, that's not true and that's not this. So just ask your supplier. It's the best way. No further questions. If you go, where are we? There are we. Let's test. We just did that. This is the question part. Now this whole webinar will be broadcasted and will be put also on the www.4AI TV. 4AI TV is where Prolyte is also available, and the other brands of the Area 4 industry group, of course. So you can also see there the promotional videos, the product videos, whatever. In these times, maybe it's useful to take a look at it, to watch some movies and just extend your knowledge as far as that's possible, because we have very experienced people as an audience, from what I understood. So for now, the only thing what I can tell you, be strong, and we hope that we all survive and that the industry will get better soon and that all the diseases will go away, so that at least we can do our job, what we love most, and that's creating nice structures, creating emotions, gather with thousands of people in one stadium and listen to that top rock concert. So be strong, think positive, please, and most important, stay safe, you and your family, of course. And thank you for watching and that you took the opportunity to look at this webinar. Thank you very much for that, and I hope to see you all back in a bright future. Thank you very much, and goodbye. Bye.
A4i.tv, rigging and trussing television. Be the first to see the newest and most dynamic videos on A4i.tv. The world's first internet TV channel fully dedicated to trussing and rigging. A4i.tv. A4i.tv, rigging and trussing television.